Welcome, stargazers. If you will, point your trust, and picture a heavenly event so huge that it creates shaded areas on Earth, readily apparent without any effort to conceal that scene, which may be near us, the very edge of Orion's vision. The Betelgeuse star constellation is acting strangely, indicating a looming cosmic explosion that will illuminate our sky more than ever. But when will Betelgeuse go supernova? And what will it mean? According to researchers, it appears this celestial event could happen soon. What secrets might it contain? Discover with us as we delve deeply into the specifics of the actual situation with Betelgeuse and the effect it could have on Earth, and possibly on the entire system of nearby planets discovered around 650 light-years from Earth. Betelgeuse, in the Orion constellation, isn't merely a normal star. It is a red supergiant, one of the largest, if not the largest, shining stars we know, radiating with a brilliance over 100,000 times that of our Sun. But why does this red giant matter so much to us? Betelgeuse not only stands out for its brilliance but also for its history and importance in human culture. Its Arabic name expression, Yad al-Jawza, the Hand of Orion, has been known for centuries. Betelgeuse has been observed in Orion and documented by previous civilizations for hundreds of years. It has served as a travel guide and a mark of wonder for astronomers, made distinct by its reddish hue among the stars of the sky. Imagine the constellation Orion, one single star looming large over our entire solar system. To give some perspective on Betelgeuse's sheer magnitude, if it replaced our Sun, its edges would extend all the way to Jupiter. How could a single star accomplish so much? Formed around 10 million years ago, it is considerably younger than our 5-billion-year-old Sun. However, due to its enormous size, Betelgeuse burns through its material much faster, predicting a shorter life expectancy than other stars. Now, this celestial behemoth, traversing a volume big enough to contain more than 1 million suns, is approaching its final cycle. When such large stars reach their twilight years, they don't simply fade, they exit with a cosmic explosion and an extravagant flare. A blast so brilliant and energetic, it could dominate a whole galaxy, producing areas of excellence spanning vast distances. The last time Earth witnessed a supernova blast this close was in 1604. The event, known as the Kepler supernova, was visible to the naked eye for more than half a year, outshining all other stars in the sky at night and even observable during the day for several weeks. What do these heavenly relics reveal to us? Ancient documents from Chinese, European, and other civilizations describe the appearance of this new star. Evidence of that blast remains today in the form of a cloud of expanding debris, visible through modern telescopes, giving us insight into the violent ends of massive stars. Supernovae have been rare for Earth observers. However, just imagine, a stellar explosion so intense it rivals the brightness of a full moon, casting shadows at night and even being visible in daylight. The radiation from such an event could affect Earth's atmosphere, satellite operations, and possibly even the climate. Betelgeuse's erratic patterns of dimming suggest it might be preparing to put on such a grand display. We may be on the edge of witnessing one of the most significant stellar events in our universe. Astronomers made a surprising discovery. Between mid-2019 and October 2023, Betelgeuse underwent a remarkable transformation, capturing the attention of skywatchers around the world. This was known as the Great Dimming, an unprecedented drop in brightness for a star that had remained consistent for centuries. The change was so noticeable that even casual stargazers saw it, comparing Betelgeuse to other stars in Orion. This means that not only are we perhaps just decades, or even less, away from witnessing its supernova, but that Betelgeuse is actively changing now. By April 2023, cosmic observations revealed that Betelgeuse had resumed its previous brightness levels, leading many to believe that the anomalous period ended in a dramatic rebound. The star's brightness surged again, intensifying by an astounding 50%, a surprising shift for a star that had previously followed predictable luminosity cycles. What caused this sudden change? Why did one of the most familiar stars in our night sky suddenly throw us a cosmic curveball? Stars don't just shine, they live, breathe, and die. They are dynamic entities with life cycles, behaviors, and, for some, mysteries. For Betelgeuse, the brightness cycle had long followed a consistent 400-day rhythm. But the Great Dimming defied that pattern, challenging our understanding of stellar behavior. Are we on the verge of a cosmic revelation? While the exact cause of Betelgeuse's abnormalities is still under investigation, a compelling hypothesis has emerged. This hypothesis centers on stellar activity and mass ejection, comparing the star to a cosmic volcano quietly expelling vast quantities of material into space. Recent data from the Hubble Space Telescope confirmed that Betelgeuse had expelled a massive amount of surface material, an event 400 billion times larger than typical solar mass ejections, equivalent to several times the mass of our Moon. This ejection likely formed a thick dust cloud that temporarily obscured the star's light. When that dust began to disperse or was blown away by stellar radiation pressure, the brightness returned. One way or another, these events reveal that Betelgeuse is far from finished, possibly approaching the twilight of its life. A sudden outburst of light caused by a supernova could eclipse an entire galaxy. It would appear as a flash on the horizon, caused by unexpected changes in the star's core. This can happen when a star like Betelgeuse runs out of nuclear fuel. Without energy to counteract its own gravity, the core collapses. But what drives a massive star like Betelgeuse to its end? It all starts with clouds of gas, where gravity pulls together hydrogen to form a star. In its early life, called the main sequence phase, the star fuses hydrogen in its core for billions of years. As hydrogen depletes, the star expands and begins to burn helium, forming oxygen and carbon. It then transitions through more stages, burning heavier and heavier elements, until it starts producing iron. Iron fusion doesn't generate energy. So, once iron builds up, the star can no longer resist its own gravity. It collapses, triggering a violent supernova explosion. So, is Betelgeuse nearing its end, or simply taking its time? Ongoing research by Japan's Tohoku University suggests that Betelgeuse might currently be in its carbon-burning phase. Scientists believe the core could collapse within a few years once carbon reserves run out. However, not all researchers agree. Studies from Hungary's Konkoly Observatory suggest that Betelgeuse is still in its earlier helium-burning stage. Yet despite these differing theories, one thing all scientists seem to agree on is this. Betelgeuse is set to become the Milky Way's next great supernova. When Betelgeuse does eventually go supernova, it will mark a moment in cosmic history, one we may witness with our own eyes. Astronomers predict that the explosion could shine as brightly as the full moon, possibly even visible during the day for weeks or months. But what happens after the explosion? Once Betelgeuse collapses and explodes in a supernova, its core will be all that remains. Depending on its final mass, this could lead to the formation of a neutron star, an object so dense that a single teaspoon would weigh more than 1 billion tons, or possibly even a black hole, if the remaining mass is high enough. Both outcomes would be monumental. A black hole in such relative proximity would offer scientists a once-in-a-lifetime opportunity to study gravitational waves, space-time distortions, and the physics of collapsed matter. A neutron star, on the other hand, could become a pulsar, a spinning beacon of radio waves, pulsing rhythmically through space like a celestial lighthouse. Despite Betelgeuse being located 650 light-years away, its explosion wouldn't pose a direct threat to life on Earth. That distance is enough to shield us from the most harmful radiation. However, the supernova would still provide valuable insights into the life cycles of massive stars and serve as a real-time demonstration of theories we've only tested in models or observed in distant galaxies. For generations, humanity has looked up at Betelgeuse as a steady sentinel in the sky, an anchor in the ever-shifting cosmos. And now, we stand at the edge of one of the most dramatic moments the universe can offer. This could be the first time in recorded history that we witness the death of a star of such magnitude so close to home, an event that reminds us both of the vast scale of the universe and of our own place within it. The countdown has already begun. Will Betelgeuse go supernova within our lifetime? No one knows for certain. But whether it's tomorrow or 1,000 years from now, the story of Betelgeuse is a reminder. Even the most brilliant stars eventually fade, only to give birth to new beginnings in the chaos they leave behind. Stay curious. Keep looking up. The universe is writing its story in light, and we are here to read it. Next supernova? Securing the event's timing remains a vast game of guessing, with wagers ranging from a few years to 100,000 years. These scientific discussions and speculations regarding the future of Betelgeuse bring up one undeniable fact: the very nature of what we see when we look at the night sky. Observing the starry field above, there's a subtle paradox that is frequently overlooked. It lies in the very concept of time, stars, and light in our vast universe. Since celestial bodies are so far away, their light takes an immense amount of time to reach our eyes. Though the speed of light is an impressive 186,282 miles per second, it still means that light from distant galaxies and stars takes years, sometimes centuries, to traverse the vastness of space before it reaches us. When looking at Betelgeuse, you are in fact witnessing a spectacle from 650 years in the past. To put that in context, when this light began its journey to Earth, the Renaissance was just unfolding, and adventurers like Marco Polo were leaving their mark on history. Every observation we make of Betelgeuse is like peering through an immense time capsule that provides glimpses into the distant past. For example, if Betelgeuse had already exploded in a brilliant supernova, we would not be aware of it for another 650 years. So while we study and predict the approaching supernova, somewhere out in the vast universe, this amazing event may have already unfolded. We're simply waiting for it to traverse the distance between reality and the moment our eager eyes finally witness it. The most recent Betelgeuse-related discoveries have sparked heated discussions within the astronomical community, shifting their focus to a different shocking revelation, recently observed SN 2023X. This recently spotted supernova, occurring in a galaxy near the Milky Way, evoked memories of the fascinating and mysterious dynamics of the universe. SN 2023X was unique in its own right. Found millions of light-years away, it showed an intense burst of brilliance that instantly outshone its host galaxy. What specifically piqued my interest, as well as that of researchers and casual observers, was its uncanny resemblance to what many expect will be Betelgeuse's fate. The distance, power, and effects of the explosion offered a tantalizing glimpse into the processes that these enormous stars undergo as they approach the end of their life cycles. For many, SN 2023X served as a preview of what might happen when Betelgeuse meets its fiery fate. The order of events observed with SN 2023X, and the link between these two celestial occurrences, point to a larger theme: everything is connected, whether it's a neighboring star like Betelgeuse or a distant one like SN 2023X. These cosmic supernovae phenomena remind us of the dynamic and ever-changing nature of space. Beyond physical and astronomical implications, the impact of such an explosion would carry consequences for human culture. The sky, noticed and admired for centuries, would change, leading to reflections on impermanence, the enormous dimensions of cosmic time, and our place in the universe. Such an event reminds us of the ephemeral nature of existence and our eternal journey to appreciate the magnificent past. Contemplating Betelgeuse's potential supernova is essential for comprehending the larger implications of such an event on our cosmic neighborhood. When Betelgeuse finally comes to an explosive conclusion, it could impact not only our immediate vicinity within the Milky Way, but also the dynamics of the interstellar medium. The shockwaves produced by the supernova will create vast regions of ionized gas, enriching the surrounding space with heavier elements forged during the star's life cycle. This process plays a vital role in the great matter cycle of the cosmos, encouraging the formation of brand new stars and planets, containing the necessary elements for life. Furthermore, the light from the impending explosion could act as a cosmic laboratory for astronomers. By studying the spectral and light curve characteristics of the supernova, researchers could acquire invaluable information about the life and death of massive stars. Every supernova offers a unique glimpse into the physical processes operating in the universe. By studying these cataclysmic events, scientists can refine their models of stellar evolution, contributing to our understanding of the universe's life cycle. In addition to scientific advancements, a supernova can have cultural repercussions. After all, significant cosmic events have historically influenced art, literature, philosophy, and creative expression. The brilliant appearance of Betelgeuse's supernova would likely inspire a new wave of contemplation and reflection across the globe, prompting people to reconsider their place in the cosmos. This event could rekindle interest in astronomy and science, much like the curiosity that emerged during the Renaissance, when celestial observations began reshaping our perception of the universe. From a practical perspective, a supernova's effects could reach technology. Elevated levels of radiation pose threats to satellite communications and navigation systems. These implications would necessitate improvements in shielding and protective technologies, extending engineering's boundaries in space exploration. As we continue to rely more heavily on technology, understanding and adapting to these cosmic events is crucial for mitigating their effects on our daily lives. The supernova could also change our perspective on time itself. The event's fleeting nature serves as a reminder that even monumental celestial bodies are not eternal. This realization might prompt philosophical debates concerning existence and the transience of life. The universe operates on timescales that dwarf human lifespans, but we find meaning in our brief moments under the heavens. And so, as we await the inevitable fate of Betelgeuse, we are reminded of our own impermanence. This single star, hanging in the constellation Orion, holds within it the power to transform not only the sky, but the very way we perceive reality. When it finally reaches its terminal explosion, the light show will be unlike anything modern humans have seen. For weeks, possibly even months, the star could shine as bright as the full moon, visible even during the day. It will dominate our skies, becoming a beacon of cosmic transformation. But more than its spectacle, the supernova will serve as a mirror. A mirror to our fleeting existence, to our insatiable curiosity, and to the stories we tell about the cosmos and ourselves. This is where science meets wonder, where empirical data walks hand in hand with the poetry of the universe. As we record light curves and spectra, we'll also be capturing emotion, awe, and perhaps a collective moment of human unity. Because Betelgeuse, in its final act, will offer something rare, a shared cosmic event experienced in real time by a planet full of watchers. In that moment, borders will blur, and timelines will overlap. Astronomers, poets, children, and dreamers will all gaze upward, some seeking answers, others simply caught in the beauty of it. The legacy of such a supernova will ripple through generations. Future astronomers will study its remnants, artists will depict it in paintings, symphonies, and novels. It may influence theology, inspire renewed interest in the heavens, or provoke existential inquiry into the fate of our own sun and solar system. Teachers will tell young students, "I remember the night Betelgeuse became a second moon," passing on the memory of light from a star that died long before our ancestors walked the earth. And long after the bright flare fades, the echo of Betelgeuse's death will remain, in nebulae, in scientific journals, in whispered legends, and in the collective memory of Earth. So we wait, not in fear, but in reverence. Not just for the spectacle, but for the understanding. In that waiting, we learn about stars, about time, about ourselves. Because to watch the death of a star is to witness the universe breathing.